Est-ce que vous m'entendez? Parfait. Allô, allô? Hi, everyone. C'est bon pour la rediffusion? Parfait. Welcome. Bienvenue à Montréal Python. Je m'appelle Mélanie. Je suis présidente de Montréal Python. I try to switch in between the French and English. Sorry for my English, it's very bad, but I try it. So welcome for this conference. Before to start, I like to know what are you? So for who is first time? Pour qui c'est la première fois à Montréal Python? Okay, great. Welcome. Thanks to come. Congrats. Perfect. Qui est étudiant? Who is student? Perfect. So just please, the student. Okay. Who come from NAD? Qui vient du NAD? Ok, quelques-uns. Perfect. Qui travaille dans le milieu du développement? Who work in a dev? It's developer. Perfect. Great. Who speak French? Qui parle français? Nice. A little bit. And English? Ok, bilingual. Perfect. For the new people, pour toutes les nouvelles personnes, je vais vous présenter un peu Montréal Python. Montréal Python est une association qui promouvoit le code Python. It's association to promote the Python code with conference, with workshop, and we have a Je vais switcher, c'est correct. Donc, ouais, on a une grosse communauté Montréal Python. C'est une association qui existe depuis 2009, qu'on a repris là après la Covid. C'est une association qui est totalement gérée par des bénévoles. So it's only volunteer manage the association, organize the conference, the workshop. So if you want to help the association, don't hesitate to see me. And I'm happy to explain what you can do in association. And to leave Montreal Python need a sponsor, so some enterprise support Montréal Python. Donc nous avons cette année Savoir-faire Linux, une entreprise de développement logiciel qui nous supporte, qui nous a déjà soutenu l'année dernière, qui nous soutient encore cette année. Est-ce qu'il y a quelqu'un de Savoir-faire Linux ce soir? Non. Okay. Et on est soutenu aussi par la Python Software Foundation. So we have another sponsor, it's Python Software Foundation. It's help to pay the meetup subscription and for the pizza after the event. And we have a FGNR sponsor. It's a basic sponsor to help the server and other thing for Montreal Python. Mais si vous êtes une entreprise ou vous connaissez une entreprise qui veut soutenir une association, n'hésitez pas à venir me voir. So if you need know some enterprise can help the association, go to see me. And it's a pleasure to support by other people. Today we have two conferencers, two women. I'm very happy. Congrats. The first is Arul, talk about more several web app with Python. And after we have Erin talk about the tool of animation using Python. And yes, and so we start with two conference. And after I share you some next date for Montreal Python. And we have a pizza after this conference. So the first hour, if you want to come. So, yeah. So just 2 minutes to check everything.
So, hi everyone. Yeah, hello everyone. This is Arul. I'm currently working as a cloud engineering lead at one of the startup company called Watson. So, I'm here to talk about the code from code to cloud. So, the serverless way. So, we are going to build and deploy the basic web application written in Flask to the GCP Cloud Run. So we are going to talk what is the architecture and what is serverless, and we are going to demo on how to deploy the basic web application, and we are going to test it out. So this is the agenda for today. Uh, yes. Going on to the architecture. So, when you write a Python code, so where do you test it out? So you either test it out in the local, you have to write all the dependencies, you have to install all the dependencies, and you have to test the code. So instead of doing that, you can use the GCP credits. So when you log in for the first time, you'll have $300 credits. So you can utilize that for testing your code. So this is the architecture we are going to see today. So we are going to utilize CI/CD principles. CI is for continuous integration. So when the developer pushes the code to the GitHub, that's a repo that stores your code, and there is a GitHub Actions that handles our CI. So we will write the pipelines to handle it perfectly, and once the developer pushes the code, it will trigger the build. So your code will get containerized and built by using the Docker container, and we are going to build and push the image to the Google Cloud. So Google has the artifact repository, so that is like a repo for your Docker images, like a Docker hub. So we will be pushing that image to the artifact registry, and we have Cloud Run and GCP and API and Cloud IAM to give all the permissions and the API configurations and stuff. Once we push the code to the Cloud Run, it will give us the cloud endpoints. So that endpoint is the API that we are going to test it out. And we are going to do all this infrastructure provisioning using the Terraform. This is the infrastructure as code. So why serverless? There is no server management. You do not need to maintain the server. You do not need to provision the server. And the big advantage is automatic scaling. So when you use the Cloud Run, you can specify the minimum number of instances and the maximum number of instances that it can be automatically scaled. When there is no request for your application, it will scale down to zero. So there is no cost. The cost, this is cost efficient, I would say, because uh, you are going to pay when there is a request to the API. So only when there is a request, it will be paid. Then this is event driven. The Cloud Run can be event driven, so it can act and react to the events, like when you're uploading a file, or maybe when a message is published in the PubSub container, or when you're hitting the endpoint. That time, the application, the container will get triggered, and it is faster time to market. It's easier to build the deployments and stuffs. So our simple Python web application is this. So we will have two endpoints. One is for get and one is for post request. So I'm just giving a simple message like hello from Python, and here for the post, we are going to send a data and we are going to retrieve it. So this is a basic web application, Flask web application with two endpoints. The next is we are going to containerize the code. To containerize, we are going to use a Docker file. So we are going to pin the requirements, like pin the dependencies in the requirements.txt. And this is the Docker file. We are going to use the Python slim image. We are going to copy the requirements, install it. Then we are going to run this our application in the port 8080. So we are going to expose this port as 8080, and we are going to connect the Cloud Run with this container to connect via this port 8080. Next, once we have written the Docker file, we are going to build and push it to the artifact repository. So to push it to the artifact registry, you should have the repo created already. Uh, so these are the environmental variables, and this is the command to create the artifact repo. And we are going to authenticate the Docker with that location. So I'm going to use North America Northeast one. That's the Montreal location for GCP. And I have created a project already. So when you're creating a project, create a project, set up a billing account, then only it will be uh, enabling you to enable all the APIs related to Cloud Run or to use the artifact registry and stuffs. So enable all those APIs before. Then this is the image location just as a variable name with the location, project, and repo in it. And that's my image name, and that's the tag. So here, I'm going to build this image and push this image. So this will automatically push the image to this location. Next, to deploy on Cloud Run, we can do it in the console. I'll show you how to do it. Yeah, so we can also create the repository, artifact repository in the console also. So it's like creating a repository. You have to choose what type of repository it is. So we are going to build a Docker image. So click on Docker, choose the region, and just keep all the other variables configurations default and create. And similarly, for the Cloud Run, we will have the same method, like deploy container. So for the Cloud Run, we will have like three options. Like we are going to deploy using the image that is inside a Docker Hub or either in the artifact registry. Otherwise, we are going to integrate that with the GitHub, directly pushing the code from the GitHub repo to here. Or you can create a cloud function. Cloud function is a direct code without a container. It just uses to create events, like here the events. And we have to give the image URL here, the service name, the region, and we are going to give the authentication and the billing, all the stuffs. And there are configurations set up here. So how your settings would be, like how the memory, the CPU, or if you want the Cloud Run to be used by GPU, so you can use the GPU, add health check, and you can store the variables and secrets, everything here in the console. So instead of doing that, it is okay for demos. You are creating a simple project. It is okay if you create it in the console, but it is difficult if you want to maintain the consistent environment. If you are in a company and you have to collaborate with the other team members, that what are the configurations, and it should be consistent across all the environments, because in a company we will have like production environment, test environment, or the developer environment. So if you have to have the configurations and the variables, everything to be inconsistent with each other, we are going to use the utilize the Terraform, like the infrastructure as code. So we are going to have code written like to provision the entire infrastructure within a code. So I'll show you the sample of how the Terraform code will be. Sorry. Yes. Yeah. So this is the Terraform code. This code is provisioning the Cloud Run service today. So we are going to give the provider, that is Google. So we are going to use a Google provider. So similarly, we have like Azure and AWS. So if you want to use, you can choose that provider, because Terraform is common for all the providers. So you can choose the provider there. And we are going to create two resources. The first resource is Cloud Run. So this is the Cloud Run service. We are going to give all the things that we saw on the console. So we have the name, location, and the image, and the traffic percentage. and the latest revision is true. So we are going to set the latest revision. And to access that Cloud Run service, we are going to have the IAM permission. So we are going to create another resource called IAM member, and we are going to set that role to uh, run.invoker. This is the Cloud Run. This is the invoker role. So we need this invoker role to call that Cloud Run that we are going to create. And for the member, you can always choose your email for like authentication, or you can use the service account. For now, it is like I'm going to make this Cloud Run as public, and I'm going to use all users to give all permissions to access that Cloud Run. And once the Terraform core is written, there are like three simple commands. One is the Terraform init that just set up the backend and the providers. Then the plan and apply. So the Terraform plan command just gives you architecture in a JSON format that will show you what are the changes or what are the modifications to be added within the current infrastructure. And the supply command is the one that provisions the resources. And once that Cloud Run is deployed, we are going to get the service URL, and we are going to test the GET request and the POST request using the curl command. Yeah, so this is the GitHub repo that I have. So I also have the code here. I'll show you how to do that. So this is the basic web app with the two endpoints that I have set. And I have this is under the app directory. So I have the requirements.txt and also the Docker file. So I'm going into the app. So I'm going to set the environmental variable. So I have the comments already. So just I'm going to set the environment variables here. Then I have already have the Docker configured. So now I'm going to create the repository. So I have mentioned the repository format as Docker, and the repo name is here, the web app repo. Okay. So when I go here into our artifact repo registry, so we have the web app repo created. So we are going to push our image into this repository. Yeah. And
Yes, just for online. Exactly.
okay. Yeah. Sorry. So the image with the location. Sorry. And I'm going to name that image to be web app image version 1. And I'm going to build this image now, build and push. So since I'm using the MacBook, I'm going to define the platform here. Otherwise, it will have the Mac OS build. So I'm going to specify the platform as Linux and AMD 64. Oh, sorry. So before that, you have to have the Docker running and it is authorized. Yes. Okay, now it is building. It will just take a minute or two. Yes, now okay. You can see it's been pushed there. when you go to our repo and see, this is the web app image that I pushed, and you will see the version as v1. And we have the app, we have written the requirements, and we have the Docker file, we have containerized, and we have pushed that to the artifact registry now. So with that image, we are going to have a serverless container that is running. We are going to provision that cloud run service using the Terraform. So for the Terraform, we need to have like two main files. Like we have like main.tf. Yes. So we will have the provider and the two resources here, as I have shown in the PPT, and we have the tf vars file. So this is called the variables file. Um, Here in the main.tf, so we have like three variables that we are going to write. One is the project region and the image, and I will have the variables.tf file specifying what type of variable it is, and I'm going to give the values for that variable in the tf vars file. So I have given my project, the region, and the image that we have deployed. So the image that we have deployed is inside the web app repo, and the name of the image is web app image version 1. So okay, I'm going to save this. Then we are going to run the Terraform commands now. So I'm clearing this. So I'm going to the main folder. Then I'm initiating the Terraform init. Yes, so it's been successfully initialized. And when you give the plan, so here, it will show you the service that we are going to create. So it will have the ID location. So you can see the location there that has been binded from your Terraform variables file to here, and the name is the web app and the project, so everything. And we will have the IAM creator here. Like this is the plan file. This is how it is going to create. So here in this plan, you can sorry. So here in the plan, you can see there is two to add. We are going to add two services, zero to change and zero to destroy. So if you are like adding or if you are like modifying the resources, you will have the changes here. So one to change, or if you don't want this cloud run and you're creating a cloud function, other resource or other services, it will give you the state file as 0 to destroy or 1 to destroy and 1 to add. So you can see what are all the changes happening in this one line. And I'm going to apply these changes. This is like auto pro, so I'm going to give S. Yes. So the apply complete. Resources added are 2. We can see the resources in our project. So going to, this is the cloud run. So you can traverse through the cloud run here. So you can have the all the services mentioned here. So when you click on the cloud run, you'll come to this page, and we have our app, like our container here deployed with the region. And when you click on here, you will see the service URL that is being created. So we are going to test with this URL. So I'm going to copy this, and I'm going to go to the terminal and issue curl command. Yes. Yes, I'm going to get the message. So get request is identified, and similarly we can post the request. Yeah, I'm going to issue the post request here with the name demo1. I'm sorry, it's the I'm going to specify the endpoint here because we have specified two endpoints, one with the slash, and the for the post request we have like slash echo. So at the end of the URL, I'm appending that echo here, and yes. So here we have sent the demo one, and it is displayed here. So we have pushed our Docker image to the artifact registry, and that is being utilized inside the container. And we have tested the endpoints. Next, for the discussion, we have like endpoint security. So you will have a question, how do we secure our endpoints? So we can secure our endpoints by allowing only restricted access. We can have that cloud run inside the VPC, inside the network, we can manage that. And we can issue the IAM roles, the permissions. And for the environmental variables and secrets, don't just hard code anything in the Python code or in the Docker file. Use the environmental variables. And like for the secrets, like if you are going to access a database, you have to have the password, or you have the authentication passwords. Use the secrets manager that has been already integrated in the GCP. And you can ask, what is cloud run and cloud functions? So these are the two different things. So cloud run is a container, and cloud functions is a code that hears or reacts to an event. So we can just couple them up, bind them up, and use it as a single service. And for the scaling, as I said, it is automatically scalable, the cloud run. We can give a number of minimum instances and maximum instances, and also we can give the concurrent number of concurrent requests that the container can handle. And this is being utilized for CI/CD automation, for the continuous integration, and also for the continuous deployment. For monitoring and logging, the cloud run is uh, defaultly integrated with the cloud logging session. So you can have the cloud logs, and you can have all the logs displayed. And for the container best practices, use a slim image, and use multi-stage builds and all. And if you want to roll back, you can have the previous versions will be displayed in the console. So you can just roll back to the previous versions, or if you are using Terraform, it is even safer, because you will have entire infrastructure inside as a code. So you can just apply the Terraform again, and it will have to like provision the resource. Yeah, and thank you, and this is my LinkedIn. Yeah.
Does somebody have some question? Yeah, let me get a mic. Here you go.
Thank you. How would you modify your deployment to scale the architecture horizontally for a large number of parallel uh, processes in a Kubernetes environment? The purpose here would be to mimic some sort of high performance computing environment. Do you have an easy solution for that? Might not be the best environment for that, but I think it is possible. Thank you.
Yes. So regarding that, Cloud Run always like there is a container runtime, there is a processing time. So it can only run for 50 minutes in GCP. So AWS provides the container runtime, like one, it can run a single processing request that can process up to like 1 hour. So if you want the process to be run for like more than an hour, you have to go to the Kubernetes architecture, like GKE that is provided by the Google, or maybe you have to use the VMs to provision your own applications there. So this setup is for like a easier version that can run up to like 50 minutes, but it can handle like maximum number of requests. So if there are like 1,000 requests or 100 requests coming in, so we can uh, enable the GPU, and we can specify the number of instances that it can handle, and we can also specify the concurrency, like at a time how much it can handle. So we can all specify and configure that in the Cloud Run. Yes, for all the three. So for a single request, it is like 0.010 USD.
Does somebody else have some question? Yes. What is the startup latency? So if you have an endpoint that's not getting a lot of traffic and you've got 0, and then suddenly you start to get traffic, how much latency do you have, considering you're dealing with a whole big Docker container and everything that needs to be loaded? If you've got a lot of code and stuff, is there a big startup latency, or your users going to be waiting for it to start up, or how does that work?
So it can start up instantly. So if that is started up, you won't get bills for that. But this is like a pay per request. So when the request arrives the container, then you will get charged. So it will be like already scaled and already uh, set up inside the GCP, so that it won't take much time to start up the container or to be scaled up.
Are there any metrics anywhere that where you have some sort of metrics onto what that is in terms of how long the latency? Because certainly if it's at 0, there's no traffic, you're not getting charged for it. It's dormant. At some point, the code has to be brought up, and activated.
Yes.
On the request. So there must, I mean, once it's running and there's many requests, it shouldn't be an issue. But if there's no request, my understanding is there's always some sort of latency there. And considering you're dealing with Docker containers and all kinds of overhead, what's that like? Is there any data that you have in terms of that?
No, I don't have any demo data with me, but the scaling is automatically done by the GCP. We do not have to uh, like any metrics sort of things we have to maintain. So it will be all be done by the GCP automatically.
Yeah, I don't know if I can help, but I use it a lot for a lot of different customers for my company. It takes approximately 1 to 3 seconds max. It really depends on the size of your Docker image. But as she said, it's already all pre-built. So if you go from 0 to 1, yes, you have some seconds. After that, it's good. It just really does a 0. But you can pay on Cloud Run to have an instance that is always up, or even 2, or even 3, or even 5 if you want. So you can have always a hot start if you want. That was the question, okay.
I'm assuming since you're running in a Docker container, there's no limitations on the types of Python packages and stuff that you can run in the container, or is there limitations in terms of Python libraries and so on that would be supported?
Sorry, I don't get you.
So, are there any limitations in the Python libraries that can run inside the container? So can you like run
No,
NumPy, pandas, stuff like that, like really intensive libraries, or
yes.
or are there any limitations in that respect?
So there are no limitations. So we can add any number of dependencies inside the container. But if you are going to run a container, it will have only 15 minutes to run. But if you are having like heavyweight models, we can always utilize the Vertex AI. So we can push our custom models to there, and that is already a container, so we can access that endpoint in our code using a cloud function or a Cloud Run.
Does somebody else have another question? I just have one on my side. I use it a lot, but my big limitation is about the asynchronous task. Like if you want to use Celery in your Flask application or something like that. Did you already work on that? Do you have a solution to play it with the serverless part?
No.
No?
I
Okay,
don't.
no problem.
Yeah,
I will
thank
continue to search. Thank you a lot.
Thank you.
thanks. We just switch with Erin, just 2 minutes, and we restart. C'est bon pour toi, ça se sent plus? Non? Perfect. Do you prefer that or that?
Do you need a chair?
You can put in your pocket.
Okay. Thank you.
Nice, perfect. Yes.
Thank you. Is that okay? Okay, hello. My name is Erin. It's the first time that I'm here in.
Maybe it's that. Right?
Hello? Hello, hello, hello. Echo.
Ça, c'est la souris de son ordinateur. Ça, c'est la souris.
Hello, hello. Hello, hello. Yes? All right. Thank you so much. So my name is Erin. Erin Morales. It's my first time here in Python Montreal. And I'm going to talk about developing tools in animation using Python, either in Houdini or Maya. So first, I'm a senior CFX artist with more than 6 years of experience in the animation and VFX industry here in Montreal, Canada. I studied in the University of Monterrey, that is in Mexico, and then I got a master degree in UTAD, that is in Madrid, Spain. So these are some of the movies that I've worked on, starting in 2019 with Maleficent 2, and recently with K-pop Demon Hunters and Gold. These are some of the studios that I've worked at. And right now I'm working in Sony Pictures Imageworks. So I'm going to talk about a little bit about character effects, which is the animation of cloth, hair, fur, and feathers. It's a little bit in between animation per se, animation of characters, and effects. So in this case, there's a little department that is called character effects or creature effects if you are looking at VFX Studio, and we are like animators, but for with physics, for cloth hair and fur and feathers. So this is a little bit of my work. You can here. Okay, this is a little demo of the things that we usually do on top of the characters. So in this case, for example, the plants, the cloth, the fur of the character, everything has to be simulated to give a secondary motion on top of the animation that the performance of the character. And for that, we extract a little bit. We take the original model of the cloth and hair, and we extract a simplified version of it to work and apply physics. So everything you see that has like a secondary motion, like this, like the fur and the cheeks, like the cloth, everything is done by us. The dress here. In this case, the capes are fake. And to do these kind of things, we usually need some tools to make things easier for us. And what I'm gonna present is more like in the scripting side of things. It's not like developing a pipeline entirely or something. It's just little tools that we can do ourselves to make these results easier. Okay, I think you can stop there. And like I said, we usually in animation work with a variety of softwares, but in this case, I wanna focus on these two, Houdini and Maya, which are the ones that I use in the character effects department, and that allows us to simulate cloth and fur. And also these two softwares have the advantage to have the ability to make scripts inside the program using Python to automate some of the workflows. So let me show you a little bit of what I'm talking about. This is Maya, and here I have a little simulation of a witch with a cape. Usually we, like I said, we take the original model, we extract a simplified version of it, and then we apply physics. We can apply wind, or we can apply something else, some other forces, but at the end, the solver is not bulletproof. We can have some little errors or things like this, like an intersection. And one of the things that I've done to solve these kind of things is this tool Well, first, here you have the script editor in which you can either program in Mel or Python. I prefer Python because that's what I learned in the university and my master degree. And this is all the code that 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 I've done for this tool. It's a little bit big, but you can anytime select this and drag it here, and you can have this button to access it quickly. So if I press this, I'm gonna get a little window in which I can put a name and I can select a vertex, put it here, and create this little tool, which allows me um, to tweak my result and move things around from the simulation that I have already done. So we have some features like changing the radius of the envelope or where it is affecting, and we can also for example animate this and change it during time. I don't know, like maybe I want this to be here for some reason. And this follow my animation and follows um, the keys that I put on this. So this tool is meant to fix this kind of issues, this kind of intersections that we always get when simulating cloth and hair. And in the Houdini side, we have like this example. Like I said, this can be our original model. And to work on these kind of characters, we first need to separate each piece um, to work um, on each one individually. So the options that we have here in Houdini is maybe to put a split, which is this that we can select, and from one output we have the selection that I did, and in the other output I have everything else. But to work in this way, I will need to put many of these splits concatenated and select each part individually. This is something that I don't like, so I prefer to work with Blast, which is, I think, a little better, but I can select a part and just keep that part, and I just have one output. But I need to do this for each part that I want. So it's a tedious task when you have too many parts in your character. So what I did is make a script which makes this little window, and to use it I have to have here this attribute that is called path attribute, in which defines each one of these elements. So I select this, I press this button, and here I put path, and then I scan, and this gives me all the little pieces that the character has. So I can select them all to create a blast for each one. But in this case, since we are trying to simulate cloth only, we don't need the nails, we don't need the eyes, the eyelashes, maybe the body. And let's say that everything else it's good to go. So I press OK, and the script creates this kind of situation in which this creates one blast for each garment that I selected. And also creates an inverse blast that is everything that I didn't select. So yeah, I think this is kind of what I have to present you. And we mostly use Python to accelerate our workflows and to, like you can see here, for example, in the script, we don't usually use many libraries external to what the program does itself. It's just to accelerate the tedious task, right? So here we can see that I'm using PySide for the little UI that I have, and
Can you
these
just try to
two
zoom a little
libraries.
bit on the contents?
Sorry,
Can you
what?
try to zoom a bit on the contents?
Oh, I actually don't know how to. Oh, sorry.
Control plus could be
Yeah.
an option, yeah. Perfect. Maybe a bit more, is it okay for everybody? Seems good. Perfect. Thank you.
Nice. Thank you. And yes, this so much shorter than the other one. It's just 100 and something lines, but yeah, it also what it does is not that complex. Another feature that it has is that we can either use primitive attributes or groups that we predefine here in Houdini, like let's say that I want this to be a group, and I want this to be another group. So now if I run the tool, I can select primitive groups, hit scan, and I put the same name, but let's try again. Here you have the two groups. So you can select them and it will create the two blast and the inverse, which in this case shouldn't have anything. Oh no, I'm lying. Yes, it have all the rest that I didn't select in the other group. So yep, can you go back? Okay, and well, and this is my little school in which I teach how to do CFX and how to learn Houdini, and we also learn how to program and how to do these kind of tools. Um, it's just my way to make friends. So if you want to join, you are welcome. And that's it. Thank you.
Thank you for the presentation. Does somebody have a question? Yes, multiple people.
First, thank you so much for this great presentation. It's the first time for me to, behind the scenes stuff after a film. I think it's a lot of work. So my question is, like for kind of each different character, the Python script, like, do you have you can reuse a template, or like you need to manually, create them from scratch? Because I see there are many vector values for each part of a character. So how kind of you do that? And just want to know kind of the how say. Uh, the return of the investment of your time to develop a Python script, because it's development means debugging, etc. So
Yeah.
yeah.
Usually when you get like in a studio, when you get the character from another department, it already have this attribute in which it defines which part of the body it is, like its name, right? But like I said, you can, if you don't have this information, you can have your own groups made directly in Houdini, and there's an option also to use those. So yeah, in theory, you can use it with other characters and with other type of information. Like for example, usually in rooms that are the hairstyles of the character, you have many parts and are named different. And maybe this attribute is not called path, it's called name, or it's called differently, right? But the good thing is that you can put the name of the attribute, and it's gonna identify uh, all the different variations of this attribute, or the different values of this attribute, so you can select the one that you require.
Great, thank you.
Can I add something? Also, in many cases, this is industry standard. So it really depends on what studio you are and what their procedures are. But a lot of these uh, naming attributes or, oh, sorry. Okay, sorry. So as I was mentioning, this is mostly industry standard. You have dependencies behind and after you, and everyone has a little pipeline to follow. So you would know what you will receive, and you would know what you will, you know, give after, and you can also use that as reference to know what to use as reference in your thing.
Yeah, by the way, she is my wife.
Yes, and I
She's
also
also a character effects artist and also work in Sony in the industry. So
yes, but I don't know how to program because I am scared of it.
yeah, thank you.
Uh, Really cool.
Thank you.
Thank you. The couple questions, I guess. The little form, I saw the blast gen tool there, and then there is a little form. The form you define in the script itself, right? The fields, the Dropbox. etc. I saw that the code has like a class on it, and it looks fairly large in a single file. Do you have ways to debug that? Can you edit that outside in something like Visual Studio Code or something like that? How do you manage that? Because it looks quite complex, like for
Yeah,
that window.
yeah, thank you. What I usually do, like I use this kind of parts of the program, like the script editor or the one in Houdini, when I'm doing something very simple, to be honest, like just a couple of lines or things like that. But if I'm doing projects more like larger projects, I usually use it's called sorry, Sublime, Sublime Text. Yeah, because it has colors and it's easier. Yeah.
But do you have like debug capabilities? Like, can you put like a breakpoint and stuff like that?
No, like it helps me to check more like the typos that I have. Then I have to copy paste to here and then run the code. And this part, it tells me what I'm doing wrong too. Like it tell me like in this line you are using a function that is not, it doesn't exist or something. Like it's a back and forth. It's a little bit annoying, but it's what we have. Yeah.
Just to know, because I already did it, you can also plug your ID on the file and just use the file in
Oh
Houdini
yeah.
directly. So you can use your ID for everything if you want.
I'm surprised that with Houdini and in Maya, uh, there are only tools that you can use in which you can inject Python script. I would imagine that a more, how do you say, powerful platform like Flame would also allow you to do that. You mentioned you can inject Python, and what else? You said, I heard you say Elm.
Mel,
I think I misheard.
Mel.
Yeah, okay.
Yeah, Mel is like the proprietary. Yeah,
Okay.
that.
Okay, I understand. So you don't have this capacity at all in Flame?
I know that Maya is also um, compatible with C++, C++.
Mm.
But like I said, it's more in the scripting side of things. This part is not. It's kind of to. I see it in the way that it's kind of a prototype here, or to help myself, or maybe my coworkers. But then these kind of tools, if it is working fine, I can send it to software, and they do the other thing, the others implementations. But I don't know about Flame or yep. Oh.
Getting intimate here. I think also more than using Maya because of Python is we use Maya because that's the industry standard for 3D. So I would say 90% of the studios for animation and visual effects, they will use Maya. And maybe amazing studios like, I don't know, Weta or ILM that have their own magic that they put into, they can implement how to get other powerful. We know that Weta works mostly with programming, like they don't have much of a visual 3D input like most of us mortals do. But that depends on the infrastructure of the studio that they can use external tools that are not into Maya by default. And it's the same with Houdini, I would say. We're constricted by what the industry mostly uses, I would say.
Thank you.
Did you add a, yeah?
So one quick comment first to you and to the previous presenter. I think this is the first time in a long time that I've been to a meetup where we haven't discussed AI. So thank you very much.
Okay. Yeah.
And now I'm going to ruin that. And it seems like the type of work that you're doing would seem very appropriate to be using AI agents to do this type of stuff. Have you thought about those things, or are there people doing stuff like that?
Um, sorry, I need to leave. No, no. W- you say that this kind of work can be done by AI?
No, not like the animation, but the selecting and stuff like that. It seems that you're spending a lot of time like going and selecting stuff, and you
Oh,
could write an agent to say, give me like all the cloth, and then it would be able to tell from the attributes that you have that all these items are cloth, and it could make it faster than having to go click, thus making your job more efficient.
yeah. Yeah.
I'm not talking about obviously the animation is the animation. I'm
Um,
not talking about that. I'm just talking about the scripts that you wrote. Seems to be very appropriate that you could automate some of that stuff to another level using AI or AI agents, or that type of stuff.
Yeah, I agree. I think, for example, in the case of Houdini, I think they are not afraid. We are not afraid of AI. I think we think that it's a powerful tool, and actually, I have seen. Uh, I don't want to say like AI, but more like machine learning type of solutions for some issues. Um, I don't know how useful will be for this particular step. I mean, I think Python does the job in this case, but for example, when we have a character with too many feathers and we need to make sure that each feather is not intersecting each other, I know there are solutions made out of machine learning, and Houdini is also implementing that option, like to train your own models and things like that. So I see it more like in um, that it can help in the case of these kind of situations with too many feathers, too many elements to handle, or deformations. Because also what's interesting is train your models to skip the part of the simulation when the simulation is not right in front of you in camera. Like if you are if we are talking about crowds in the background and we want them to feel like that they have cloud simulation, maybe it's worth to train a model to have these kind of wrinkles that can give the look. And yeah,
Thank you. Very interesting.
thank you.
Another question in the room? Yeah.
Hi,
Hi.
Erin. Gracias por la exposición.
Gracias.
I'm very happy to hear the work that you're doing. I'm recently graduated from NAD school too, uh, and I think that I find interesting is the part that you explained that each character has let's say a way to be simulated. So my question is, how many time do you take to make a simulation? Let's say a feather simulation. How many time does it take you? Is it a long process? Is it a fast process? I don't know.
Okay, in that matter, we have um, two steps, let's say. we have first the developing task. It's early in the production of a movie in which we are developing the look of the movement of our simulations. So we work in walking cycles, like we have the character moving, walking or running or etc. And we develop, like, we set the physics, the attributes, the parameters that will define the physics of the cloth or the hair or the feathers. That's a first step. And then when we have actual shots to work on, um, we take that configuration that we already done and combine it to with animation. And in that process, we usually, like, as a standard in our department in different studios, we have like 2 shots per week to deliver. Um, and it's not just a matter of running the shot with the physics. We have to also take in consideration artistic notes. Like, for example, this tool that I presented first, we can also use it to move things around, like the cape, to match certain poses that maybe the supervisor is asking for. Yeah. So I would say to the for the dev process, it's around 3 weeks per character, and for the shots, it's 2 per week, at least.
Okay, thank you.
Thank you.
Another question? Yes. We'll make some work.
Thank you. Is there a big difference between video games and animation? Can the character be exported to be played in video games?
Do you mean in the simulation part of things? Well, in sorry, it's I don't really like the physics of the games because they have to be real time, and to do that, they have to sacrifice, like, accuracy, right? So what because I like, this is my work. When I see a game in which the hair or the cloth is intersecting with itself, I feel like uh, so yeah, that's the difference. I think the solvers of the physics in video games are built to solve the 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 simulation. I mean, to not break, uh, and it can mean that it gonna intersect, it gonna do tricky stuff. But in movies, we try to be as accurate as possible. Uh, like I said, is not always the case because the solvers still have some errors or some issues in which there are intersections. But in those cases, we have to go and fix them, like, manually, for they to not be in the movie. Like, so yeah, but the general concept is kind of the same. We take the high res model. We make it into a simplified version of it, and we applied physics to it. And then those that movement, it goes back to the final model. So in that sense, it's the same kind of.
Thank you.
Thank you.
Another question? Okay, I thank you then. Thank you a lot.
Thank you very much.
Thanks a lot. Just a minute to close this conference. Perfect. Just 5 minutes, and after it's a bit that time. Don't care. Merci beaucoup d'être venu pour la conférence. On aime bien partager notamment notre prochaine conférence. So the next conference for Montreal Python, it's 60 October. Vous pouvez déjà vous inscrire sur Meetup. Il y a déjà nos conférences pour octobre, novembre et décembre, donc n'hésitez pas. Et on va bientôt annoncer les conférenciers qu'on a déjà pour octobre. Et on soutient aussi d'autres événements qui ont lieu dans d'autres groupes tech. On a DevMTL, qui est une conférence, une journée de conférence qui a lieu, qui regroupe pas mal de meet-up et qui fait pas mal de conférences sur différents sujets de développement. Ils sont encore en recherche de conférenciers jusqu'au 1er octobre. So if you want to present something, it's Python or other technology, you can apply on a CFP of DevMTL. Search DevMTL in our website and you see. The last time to put something, it's 1st October, and the conference, I remember it's end of November. Et nous avons aussi Linux Rencontre Québec qui ont leur activité le 7 octobre. Donc ça se passe à l'ETS. C'est un peu comme ici, des conférences avec autour de Linux et du logiciel libre. So if you want to go in a Linux Rencontre, it's ETS. The 7 October, it's same thing, search in web Linux Rencontre Québec and find the website. Merci à vous d'être là. Et la pizza est ici, donc vous pouvez prendre la pizza. Et si vous avez des questions, n'hésitez pas à venir voir nos conférenciers ou les gens du staff de Montréal Python. Ça nous fera plaisir de répondre à vos questions. Merci et au mois prochain. Yep.